Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is special digits. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement and it says that you're given 5 integers n, a, b, c and d. Okay, let us say all the integers of length n having only a or b in their decimal representation are good integers. Okay, so like I have n equals to 3 or I have a and I have a equals to 1, b equals to again 3. Okay, so I will write good integers as all the integers of length 3 like 1, 3, 3, which are having either 1 or 3 or both. Okay, or I have 1, 3, 1 or I have 1, 1, 3 and so on. Multiple possibilities are there. Okay, so these are the good integers. Okay, also among all the good integers, all those integers whose sum of digit contains only c and d are best integers. Okay, so let's see this one. You can see that it contains the sum is 5. So in case I have c equals to 3 and d equals to 5, so since d is 5, so I can say that this is one of the best integers. Okay, now our task is to find the number of best integers of length n. Since the number of best integer can be huge, so I have to print it modulo 10 is to the power 9 plus 7. Okay, so let me explain one example which is given here. Example says that we have n equals to 2, a equals to 1 and b equals to 2. Okay, so first of all let me write all the good integers possible. So I have length 2, so all the 2D numbers which are having either a or b, so I can write 1 1, 1 2, 2 1 or 2 2. These are the possible good integers. Okay, now I have c equals to 3 and d equals to 5. So first of all I am going to write the sum of all these integers. So I have sum as 2, 3, 3 and 4. These are the sum values. Okay, among all these values you can see that I have two values which are having sum as 3 and 3 is the value of c. So we can say that we have two possible best integers here. So here output is going to be 2. Now I hope you guys got the clear understanding of the problem. Let me talk about the solution now. Okay, so I'm going to take the same example where n is equal to 2, a is equal to 1, b is equal to 2. Okay, so good integers formed will be 1 1, 1 2, 2 1 and 2 2. Okay, and after that when I write the sum of these integers, so here I am explaining the steps which I have used in order to solve that particular example. So sum is 2 here, 3, 3 and 4. Okay, now we are using this sum to calculate the number of best integers. Like I can see that this sum contains, okay, so I have c equals to 3, d equals to 5. So now you can see that this sum doesn't contain either c or d, and this sum contains, so it is true for this and false for this. Okay, so now you can see that we have two integers. So one thing that I want you to notice is we are only interested in this sum array. We are only interested in the sums of possible sums of these good integers. So we are not interested in good integers. What does this mean? This means that I'm going to take even we don't have these good integers, we just have this sum array. We can find how many like possible best integers I have. Okay, so now I want you to tell something like if I have 1, 2, 3, or I have 1, 3, 2, or I have 1, 3, 1, 2, or I have 3, 2, 1. Doesn't matter what are the permutations of this 1, 2, 3. I will have same sum. I will have same sum value, isn't it? Sum will remain same. Okay, so similarly for this a and b, doesn't matter what combination of a and b I have. Like if I have a 3 times and b 3 times, so doesn't matter how they are arranged. Like I can have a b b b, or I can have a b b a a b, or there are multiple possibilities, but the sum is going to remain same for both because I have a 3 times and b 3 times. So what is the sum for this? The sum is going to be 3 into a plus 3 into b, isn't it? Like I have a 3 times, so a is going to contribute 3 multiple and b is going to contribute 2 3 times again. Okay, so now let me tell you what are the possible sum values. Like if I have n equals to, so now if I have n equals to 6, okay, and I have a equals to some value, let's take 1, and b equals to 2. Okay, so what are the possible values of sum that we can have. This is what we need to calculate. Okay, so I can have a one time and I can have b five times, is it? Okay, after that I can have a two times. Okay, so even I can have a zero times and b six times, isn't it? Like I have b and b. This is one of the possible good integer. Okay, so we are counting sum of good integers here, isn't it? Okay, so now at this position I can have a two times and b four times. After that I can have a three times, b three times, and I can have a two times and b four times. After that I can have a one time and b five times. After that I can have a again. Okay, so okay, since I have to decrease the value, right? What I'm doing here, I'm going wrong. I'm going wrong here. Like it should be like a0 b6, or I can have a1 b5, or I can have a2 b4, or I can have a3 b3, or I can have a4 b2, or I can have, this is the point from where I was wrong. Okay, so I can have a4 b2, and after that I can have a5 b1, after that I can have a6 b0. So these are the possibilities that we have, like for forming the number. Okay, now we can calculate the sum of the numbers from this particular like case only. How? I have a5, I have a0 times and b6 times. So I will have some numbers which will having like sum as okay, so I will have some number which are having sum as 6 into b. I will have some numbers which are having sum as a into 1 plus b into 5. Okay, similarly for this a into 2 and b into 4 plus b into 4, isn't it? So this way I can calculate the sum of good integers, and I don't need to calculate how many numbers which are having sum 6 into b. This is not what we need to calculate. Okay, so till now we have figured out something. We have figured out that I can simply calculate all the possible sums. So if I have n value and I have a and b, so I can find how many times I can have like how many possible values of sum. Like I have a0 b n. After that I can have a1 b n minus 1 time. After that I can have a2 and b n minus 2 times, isn't it? These are the possibilities. Okay, so I'm going to check out all the possibility for I equals to 0, I smaller than n, I plus plus. Okay, so if I have a times, like the count of a is going to be I, count of a is going to be I. So what is the count of b? Count of b is obviously, because I have total n digits and I have I times a, so n minus I times I will have b, isn't it? So this is the count of b. After that I can calculate the sum. I will calculate the sum as like a into I, because I have a I times, plus b into n minus I. This is how I am going to calculate the sum. Okay, fine till now. After that, this is the possible sum value. So what we are doing here in the example, like I have 2, 3, 3, 4 possible sum values. So I am going to check these values, like whether these values contain C or D in the sum or not. Okay, so I will calculate this sum. So I will write if check sum. Like if this is a number, so I will increment my answer. I will increment my answer. Answer will be equal to answer plus something. Okay. Till now you can just ignore what does this something means, but this value is something. Okay. Now my answer is going to change. This is simply means that. Okay. How to check the sum? How to check the sum? This is what we have figured out till now. So I'm going to wrap this thing in a box. Okay. Now how to check this sum? Simply if I have 1 2 3 4, so I need to calculate, I need to check each digit whether it is not something else than C or D. Okay, so while n, if my number is n is greater than 0, and I will calculate e digit like int current value will be val equal to n mod 10. This is how we calculate the current value, like this 4. After that I will do n equal to n by 10. So this value is going to repeatedly give me all the values, like first this 4, this 3, this 2 and this 1. Okay, I need to calculate if this value is not equal to C and this value is not equal to D, right? In that case this is not a perfect like best integer, so I need to return false. Return false. Okay, and if this loop is over and all the values are either C or D, in that case I have to return true. Return true. This is quite simple, right? So this is what we have figured out till now. Okay, now our task is to find like what is the value of this something, like what we need to add when we have this sum values as true. Okay, so when I have a particular sum value which is having C and D, so I will calculate how many numbers I can form which are having some like as some value, isn't it? Like till now we have only considered the sum of number instead of the count of number itself. Okay, so if I have sum as 3, like you can see that here I have sum as 3. Okay, so how many numbers which are having sum as 3? This is going to be my answer. So like I have 1 2 and 2 1. There are two numbers which are having sum as 3, so that's why I have written 2 here. So here again I need to calculate how many numbers are there which are having sum as 3. Okay, so how to calculate it? Now my task is calculate numbers having sum as like sum value. Sum, this is my variable. Okay, and number of digits are also limited, so number of digits as n, right? This is what we have to do, because even the question says that we have to find all the best integers of length n. Okay, now this is going to be interesting, because if you guys know what are the permutations and combinations, then you will know that how to arrange some numbers in line. Like if I have n numbers, so I'm going to for simplicity I'm going to calculate like take n equals to 6 here. Okay, and I have, let's take I have a 3 times and b I have like 3 times. After that we will derive a general formula. So if I have a and b, so we need to calculate how many ways are there in order to permute, or in order to like arrange these like these characters in this line. Okay, so how many ways are there? We know that we are like I can arrange n different number in a line in n factorial ways. Okay, this is what permutations is. Okay, after that we have repeated numbers. You can see that a is repeating 3 times and b is repeating 3 times, so I will do a factorial upon b factorial. This is how we calculate the number of ways. So it is number of ways. Okay, even you may have solved problems like how many possible ways are there to like arrange the letters in the word mathematics. I hope you guys have done a problem similar to this, like we do n factorial divided by the numbers which are repeating, isn't it? So this is what the same concept we are going to use here. Okay, so now this something is going to be this something. If you want to know more about this, like how it is actually derived, because if I explain this as well, so the video is going to be long. So if you want to know this, then you can simply search on Google like how to calculate the number of combinations of a particular letter in a word. Okay, so like this is what I can say. Okay, now this something is going to be n factorial divided by I factorial into n minus I factorial. Why? Because I have total number as n. After that I have I repeated digits which are I I have a I times, so I repeated digits, and b also I have n minus I times, so this is also repeating, so that's why I'm doing this particular thing. Okay, now okay, so first of all let me remove this. Okay, now our task is simple, that we have to calculate this particular value. So this is what this is the overview of the solution that we are going to write. Like this is the overview, this is what we have to do. Like iterate over all the values of sum. After that just check whether this sum is possible. This is the pseudo code for checking. After that I need to calculate this value, but calculating this value is something really interesting. How? Let me scroll down. Okay, so now our task is to calculate n factorial divided by I factorial into n minus I factorial. Okay, and since this value can be large, so I have to do something like mod as well. Okay, so if I do like if I calculate factorial inside the loop, then it is going to take of n times, because this is how we calculate the factorial. So it is going to increase the complexity. Like you can see here, that I'm already running a loop of n times, and inside that loop, if I also do like n factorial, then it is going to have at least O of n square time complexity. Okay, so complexity in that case is going to be O of n square. But we can do the same in like O of one time. How? You will say that, hey, we can do something like pre-processing. We can calculate an array which is factorial array. It is having n size, and we'll calculate this like factorial is 0 is going to be fact of 0 is going to be 1. After that, I will start a loop for I equals to 0, I smaller than 1 and n, and I plus plus. Okay, so even equals to n. After that, I'll simply do like factorial of I is going to be factorial of I minus 1 into the current element that I have I. I'll start from 1 here. Okay, now this is how I will have factorial of all the values from 1 to n. So I will have factorial array now, which is having all the value from 1 to n. So now I can simply do one thing, that I can write the same expression as factorial of n, this is an array now, okay, into factorial of I into factorial of n minus I. Okay, since these two values are always going to be smaller than n, and this value is n, so at most I can have n values. So that's why I have taken the factorial array size as n. Okay, now this is what we have to calculate. So but the question is, since this value can be large, and if I calculate the factorial of n, like if I divide this, then this is going to give me wrong answer. Why? Let's take the example for 14. Like if I have like n equals to 14, so and I calculate the factorial array, then the factorial array, okay, I have already written the array, you can see here. So for n equals to 14, this is the factorial array. This is a factorial array. You can see that this is 1 factorial, 2 factorial, 3, 4, 5 factorial, 6 factorial, 7, 8, 9, 10, 11, 12, 13, 14. So this is 14 factorial, this is 13 factorial, this is 12 factorial, this is 11 factorial, and so on. Okay, now surprisingly you will notice one thing, that this is 14 factorial and this is 12 factorial, but this value is something which is greater than 14 factorial. So is it always is it true that 14 factorial is like smaller than 12 factorial? No, of course it's not true. But why my factorial array is giving this one? This is because I'm calculating the mod. Like since I know that 14 factorial is something that a normal integer cannot hold, so that's why I'm calculating the mod here. So even I think I need to modify this thing. I will do something like modular arithmetic here. So I will write this to be, I want this to be long value, long value. Okay, so I want this to be mod, isn't it? After that, I need to calculate this to a long value, because only long can hold such a large numbers. Okay, so this is what I am doing, and this is going to give me this particular error. So how to cope with this error? In order to solve this, in order to solve the particular expression that we have, like factorial of n is factorial of like I into factorial of n minus I. Okay, so in order to calculate this, also we need to calculate mod. Okay, and here also we need to calculate mod. Okay, so I want to mention one theorem. Okay, before that, I want to tell that we can do this thing using the modular arithmetic. So this is known as modulo inverse. This is the concept that we are going to use in order to solve this problem. Okay, now I can do for this, I can rewrite the same expression as factorial of n multiply by 1 divided by factorial of I into factorial of I minus 1 and mod. So this is something which will provide me efficiently, because in that case, since the problem that I was having in my numerator was smaller than the denominator, so in that case, I am first calculating this value. After that, I am multiplying with this. So this is how I am going to solve the problem that I was having. Okay. Now the question is how to calculate the modulo inverse here. This is the modulo inverse. Okay. So let me mention the Fermat's theorem. Fermat's theorem is going to play a very important role in order to calculate the modulo. So Fermat's theorem, I hope I'm writing the spelling right. So it is Fermat's theorem for modulo arithmetic, modulo inverse actually. Okay, so this theorem says that if I have p as prime number and I have to calculate a like a mod p inverse, a mod p inverse. So in that case, if p's are prime numbers, like p's prime number, in that case, like I can calculate in that case a raised to the power p minus 1 is going to be 1 mod p. This is what the Fermat's theorem says. Okay, now since my task is to calculate the modulo inverse, so I can multiply both sides by a raised to the power minus 1. Okay, after that I will have a raised to the power p minus 2 here. Okay, and here I will have a raised to the power minus 1 mod p. Okay, so this means that in order to calculate the inverse of a mod p, I can simply calculate a raised to the power p minus 2 p minus 2 mod. This is what I want to say. But the question is, what is the guarantee that the p is a prime number? Since we know the value of p, right? The value of p for us is 1 e 9 plus 7, or I can say 10 raised to the power 9 plus 7. So this is a prime number. I already know that this is a prime number. So that is a guarantee that p is always going to be prime number. So I can calculate uh, p, I can calculate a raised to the power mod minus 2, and this is going to give me mod, and this is going to give me the modulo inverse. Okay, so I can summarize. I can calculate this using a function. Let's call it a bin power, a binary exponentiation method. Binary exponentiation says that you can calculate a raised to the power p, a raised to the power b. I can calculate in just of log n time, right? And I hope you guys know the method, but it is not a very tough thing to understand. So you can understand it anywhere, like in Geeks GFG. Okay, so binary exponentiation method helps us to find the power in just log n times. Okay, and if you guys want to know this in detail, so you can ask me in comment section, then I will know, let you know. Okay, so now I think okay, so let me think whether is there something else to explain. Okay, so I'm going to summarize everything. I'm going to summarize till now. I hope it everything is clear to you, like what we're doing. For here we are simply I want to show you the part where I have written this pseudocode. Okay, so I think I have written it here. Pre-processing is required for calculating the factorial array. This is not a big deal, uh, but something that is really interesting is, okay, so this is what I want to show you. This is what I want to show you. This is the main task that we have to do. Like, I'm iterating over all these sum values. After that, I'm simply calculating the sum. After that, I'm checking the sum whether it is going to have C or D in or not. After that, I'm increasing my answer by this value, and the main problem is calculating this value. So for calculating this value, we are using modulo inverse. So our task is factorial of n divided by factorial of I into factorial of n minus I. So in order to calculate this, I have rewritten this thing as factorial of n multiplied by modulo inverse of this particular thing, like fact of I into fact of n minus I mod. Okay, and after that we are calculating mod minus 2 power of this mod minus 2. I hope it's clear to you why we are doing so, because this is what the Fermat's theorem says. So we are simply going to solve this problem using this thing. Okay, now I'm going to show you the code. I'm going to show the code. After that it will be clear to you. Okay, so here I have the code, and on the left hand side I have the Java code, and on the right hand side I have the C++ code, and also I have the Python code as well. Okay, so for the Java code you can see that I'll start from this point. Okay, so this is the pre-processing that is required to calculate the factorial array, and same in the C++ as well. Okay, After that, I'm initializing my answer as 0, and for every value of sum that we have, like you can see that here I'm calculating the possible sum value. Okay, and after that I'm calculating the current sum, whether it is containing C or D or not. Okay, after that I'm increasing my answer. Okay, same thing I'm doing here. Now let's talk about a check function. So even I have explained you check function already, but for each digit in the number that we have, we are going to check whether current value is equal to C or D. And if it is not equal to C and D, then I will return false. Okay, now calculating this thing, this is something which is important. In order to calculate this thing, I am calculating the modulo inverse. I have written it as binary power because it is using the binary exponentiation method. So here I am calculating a, this is my a value, mod like a raised to the power mod minus 2. Okay, and this is how I want you to see this thing. This is how we calculate power using binary exponentiation. So this is the most efficient way to calculate the power, right? So this is going to give me power in just O of log n time. So this is all about this problem. I hope it's clear to you. Now let me show you the Python code as well. So this is the Python code. I'm even going to provide the code in the description as well, so you can visit the code on the GitHub account. Okay, so this is all about this problem. I hope the problem is clear to you and everything related to problem is also clear to you. So thank you.